Hey everybody, what's up? We're on lesson number 3, distribution and FOIL. You're actually going to see another lesson about this later on this year, but why not do it now too, just to get us more and more used to the idea. Distribution is where we'll start off. Distribution is the way that we multiply expressions together. These are called polynomial expressions, right? We have a couple of terms here separated with a plus sign, a couple of terms here separated with minus and addition signs, right? But the way that we need to multiply these terms together so we make sure everything multiplies is what's called distribution. And a lot of times the way that we show that is with these lines, right? It'll actually show that I'm multiplying each term with each term, right? And then I go back and I multiply every term here with every term. So those distribution lines, a lot of times we're going to be showing. Okay. We must be careful though that when we multiply that we multiply every term in one expression with each term in all the others. That's what those little lines will help us do. Okay. So let's take a look at a couple of examples. You're going to see it be we do together and then you try right after. So if you want to pause the video and write these down real quick, I'll give you some time to do that. So let's start off with this problem. All right, we want to distribute. I have to multiply 5 times x. That's just going to give me 5x. And then we multiply 5 times negative 3. That will be negative 15. So we've multiplied and get 5x minus 15. So I want you to try yours. Pause the video and resume when you're ready to check. Okay, let's see what you did here. Negative 3 times x is negative 3x. Negative 3 times negative 8, that double negative becomes positive 24. Okay, not a lot of work to show, but I'm going to give you a secret here. At least in this class, if you show me the distribution lines and you have some sort of answer, the distribution lines is showing me that you're doing the process at the very least, so I will give you some partial credit for showing that as your work. Because again, not a lot to show here. So if you show me at least that, and you make an error somewhere, maybe you said 5 times 3 is 10 by accident, I can still give you some partial credit. Okay, here we have 3x times x squared. Well, now I have a power situation. Technically there's a power of 1, and here there's a power of 2. When I do that, I'm going to add whatever that power is together. So that's going to give me 3x to the third here. When I multiply here, again, when we do x times x, it should give us x squared, which you've probably seen in the past. So we have 3 and negative 4 is negative 12 x squared. And now we have one final term to work with. 3 times 8 would be 24, and we'll just attach that x to it. Okay, that is our distribution. So why don't you try out yours, pause the video, and resume it when you're ready to check. Okay, let's try it. This is 2a times 3a squared. I'm going to put that little 1 there. So 2 times 3 is 6. A to the first, a squared would become a to the third. 2a times negative a would be negative 2a squared. And then finally, 2a times 5 becomes 10a. Pretty easy. Now we're going to look at a special type of distribution called FOIL. It's got its own name because it shows up a lot. We have a lot of binomials. A lot of the reason is because we work with gravity, and gravity usually works with quadratics. In fact, not usually, it always does. So we want to work with FOIL. It's a special type of distribution when we're multiplying these two binomials. The reason why they call it FOIL is because it's an acronym. It stands for first, outers, inners, and lasts. You see here right along the side. Right? First, outers, inners, and lasts. I'm going to show you an example of exactly what I mean. Okay, the firsts would be literally the first 2 in each binomial. So when I do this, this would be my F of FOIL. Then when I want to do the O's, the outers, it's the outermost 2, right? Notice how these 2 are on the outside. So I would be multiplying x times negative 2. There's your O. I stands for inner, the innermost two. So the innermost two now, if the outers were out here, the innermost two would be the 3, and the X, which is your I, and then L will be your last two in each, right? Here are your last two terms in each. So when I multiply 3 times -2, those would be my lasts. That is what FOIL is, right? Now, when we do this, we're multiplying, and because we have here an x times a constant and an x times a constant, we're going to end up having some terms that we can combine. So we will FOIL and then we will combine like terms. Okay, let's try out this example down here at the bottom. We have x minus 4 times x plus 9. So the f firsts in FOIL, I'll even write it this time for us. X times x gives us x squared. We do the outers. X times 9 gives us 9x. Inners, right here, -4 times x is -4x. And then finally, the lasts, -4 times 9 is -36. And as I mentioned, we have like terms. So we have x squared. 9x minus 4x is 5x minus 36. Okay, so you have one right here to try out. Pause the video and resume it when you're ready to check. Alright, let's check it out. We have x times x, which would give us x squared. X times 2 is 2x. 5 times x is 5x. And then 5 times 2 is 10. Hopefully you got there, no problems. Then we want to combine our like terms. The x squared will not combine with anything. 2x and 5x is 7x plus 10. Not bad. Come on, there we go. Oh, more problems for us to try. Whoa, look at that. Alright, well, I only see one term here. But I see something that says squared. So what I'm going to do is I'm going to actually expand this. That square means I have a second of that term there. So if I just write it right next to it, and now I can FOIL. X times x is x squared. X times 5. 5 times x. And then 5 times 5. Now we can combine any like terms. And we get x squared plus 10x plus 25. So I would like for you to try that one out. Remember what our little trick was at the beginning. Pause the video and resume it when you're ready to check. About ready? Let's see. X minus 3 we expand and then FOIL. X squared minus 3x. Another minus 3x. Double negatives here gives us positive 9. Check on that. Make sure you had that correct. We can combine those like terms. -3 and -3 is -6. X plus 9. So hopefully you got that correct. If not, you got to be checking your work, see where you made an error, because you want to prevent from making that error again in the future. Okay, so always checking your work if you get something wrong. Alright, I have one more example for both of us to do, and then some extra stuff that you don't have to watch. Alright, so let's try these last two. You might notice that this is no longer binomials, right? I have 3 terms here. Doesn't matter, I'm still going to distribute, and I'm going to do just what I showed you back here with all these lines. Okay? And I'm going to draw them out. This time, though, we don't need to write any letters like F-O-I-L or anything like that. I'm just going to draw the arrows and make sure that I get them all. X times 2x is 2x to the third. That was a square, by the way, I'm sorry. X times 3x would be 3x squared, and then minus 4x. So I've taken care of the first set. Now I have to go back to the 1 and then do the same thing. 1 times 2x squared is 2x squared. 1 times 3x is 3x. 1 times negative 4 is negative 4. Now I have to be careful now because I still have some like terms that we can combine. The like terms will have the same variable with the same power, right? I don't have any other x to the thirds, right? So that 2x to the third stays where it is. I do have other x squares, right? I have 3x squared and 2x squared, so that's a total of 5x squared. Now if you need to cross these out as you go along to keep track of them, that's up to you. Negative 4x plus 3x leaves us with negative 1x. You don't need to write the 1 though. And then finally, that negative 4, that's just kind of left over. So, distribution, show the lines if you need to, and then if you need to cross stuff out when you're combining like terms, it's up to you. Try out this one, and then resume the video when you want to check your answers. Alright, let's start here. 2x times x squared would be 2x to the third. 2x times 5x is 10x squared. And then finally 2x times negative 6 is negative 12x. We go back to the start. This is negative 3. Keep track of that sign. I really hope you did here. That will give you negative 3x squared minus 15x. And then finally, double negatives gives you positive 18. Okay, so that's a big challenge, keeping track of that negative that I threw at you. That's okay. Hopefully you did all right. Now we'll combine like terms. Nothing will add with this 2x to the third. 10x squared minus 3x squared is 7x squared. Get rid of those. Negative 12 minus 15. What is that? Negative 27 for our x's, and then finally plus 18. Alright. That's it for your lesson. However, before you just click out of here, there's some extra stuff called the box method. If this distribution wasn't your thing, then you can keep watching. I'm going to show you another method that I have learned in the past working with some students. Again, this is not mandatory. This is extra stuff. That's why it says extra stuff. So if you're not really the biggest fan of that, or maybe you just want another way to do it for fun, here's another way of multiplying. It's called the box method. Okay, so what we're going to do is we're going to write each of the terms of one going down and each term of another term going across, and then we're going to make a little box. We'll make sure to include any signs like the negative 4. And then we'll just kind of set up a little window looking thing here. What we're going to do is we're going to multiply whatever we see here, right? So x times x would be x squared, x times negative 4, negative 4x, 2 times x is 2x, 2 times negative 4 is negative 8. Now the neat thing about this is that all we have to do is add diagonals, and that will give us our solution, right? So if I start here going diagonally this way, x squared doesn't have anything to add to. If I add diagonally here, negative 4 and 2 is negative 2x, and then finally negative 8 doesn't add with anything. So that's another method that you can do. Now, real quick before I look at the other examples, a lot of times people complain when they see this online. They're like, why would you do that? It's a waste of time, right? Not really. It's just a different organization, right? You just saw it. We did it together. It didn't take that long to do or even set up. It's just a different organization. It gets you the right answer. That's the important thing. So if you like this method better, use it, right? I'm going to probably continue to use distribution because that's what I've always learned. And I feel like it can be, it can go a little bit further and do more stuff with distribution. But that doesn't mean that the box method is wrong. It still works. In fact, you're going to try this one out and see if you like it yourself. We're going to put x and negative 3. We'll put x and 8. Okay, hopefully you've already done this. If you didn't, why don't you pause it and try it. But let's check our solution. X times x is x squared. X times 8 is 8x. Negative 3 times x is negative 3x, and then negative 24. By the way, this we had to do with the distribution up here too. We're just making it in a slightly more different organized way. Okay? This keeps everything that we need to add our like terms. It keeps them together here. So let's see, that would be what, plus 5x and negative 24. Okay, either method works. Let's try one a little bit longer, right? This time it's not binomials. Now we have a trinomial here. It should still work. If I put 2x and 3, and then I put x squared, negative 4x plus 1. Two x times x squared, 2x to the third. 2x times negative 4x is negative 8x squared. 2x times 1 is 2x. 3x squared, negative 12x, and 3. Again, because of the way that we set this up, it shows us that our like terms are the diagonals, right? This is orange, so hopefully you'll be able to see it a little clearer here, right? My 3 should stay as a 3. When I multiply the diagonals, when I add the diagonals rather here, negative 12 and 2 is negative 10x. I should have probably started over here. It's too late at this point though. So we'll keep going. Negative 8x squared and 3x squared would be negative 5x squared. And then finally this 2x to the third. I would probably go this way from now on. I don't know why I went backwards. Why don't you try this one out, see how you do, and then resume the video when you're ready to check your answer. Alright, so you have, oops, already messed up. You have your x is your first term, negative 4. You got 2x squared, 3x, and another negative 4. X times 2x squared is 2x to the third. X times 3x is 3x squared. X times negative 4 is negative 4x. Negative 4 times 2x squared is negative 8x squared. Negative 4 times 3x is negative 12x. Negative 4 times negative 4 is positive 16. Hopefully you went this way, because last time I went the wrong way. 2x to the third. We're getting that number a lot just because of what we're multiplying. It's just a coincidence. 3x and negative 8x is negative 5x squared. Negative 4 and negative 12 is negative 16. X plus 16. That is your final answer. So we did a couple of different things in this lesson, right? Distribution and FOIL, those methods will always work. I generally will be doing that in class, but if those are complicated for you, or if you just don't like using those methods, the box method is also something that works pretty much every time. So use whatever method you choose, just show what you're doing, because that is what's going to help you in the long run. Right, I will see you at the next lesson.